From ContainerDays Hamburg, this video is proudly presented by Dax IT.
I'm Kasper. I'm super excited to be here today. This is I think it's the third ContainerDays. I was actually here for the first one in 2016, so I can see that a lot of things has happened since then. Back then it was like a small tent on the harbor, so this is way bigger than that time. So really great to be here. Today I'm going to talk a little bit about how you can break free with open standards, with OpenTelemetry and Perses. But before doing that, I will just introduce myself. As mentioned, my name is Kasper. I work as a developer advocate at Dash0 these days. Before that, I spent 8 years as a platform engineer, DevOps, SRE, whatever we call it, at a company called Lunar. It's a challenger bank in the Nordics. So if you're familiar with, I guess, N26 here in Germany, it's something similar to that. I've also spent some time in the CNCF space, being co-chair for KubeCon a few times. It says former now. I think the introduction slide just said I was a co-chair. I'm not that anymore. I've been a CNCF ambassador for quite a while, since 2019. So trying to do all kinds of things within this ecosystem, meetups. We are also doing conferences in Denmark as well, similar to this one, not the same scale. But so if you're in Denmark in next month, come by. I also challenged myself a little bit with the Kubestronaut thing, so I'm also a Kubestronaut now and took the last certification last week on the Platform Engineering Associate, which is a fun one if you are interested in that as well. So yeah, that's just a little bit about me. We also actually last week announced this free course if you're interested in sort of the gap between platform engineering and observability. It's me and my colleague, Michele. We did this cool thing with platform engineering. So this is a free course if you're interested in learning more about OpenTelemetry, all the different things that are in this space. Also Perses, and we'll showcase a lot of things there. And I will also try to do a demo today with some of these things. So the TLDR for this talk is that OpenTelemetry is really standardizing telemetry collection. Perses is standardizing how we are defining our dashboards. And if you apply platform engineering principles, it can transform observability into a seamless, scalable, and developer-friendly experience. And if we then build on these open standards, it allows you as an end user to move freely between different vendors, which is really, really cool. So that is hopefully what you will take away from this session. So let's start with observability. It's still like a fragmented space. We still talk about the three pillars of observability, or the three browser tabs of observability, if you like. So we have metrics, logs, and traces as pillars. But the fact is that we don't really have a metrics problem, right? Or we don't have a tracing problem. We have systems problems. So let's stop talking about these as pillars and talk about the problems we sort of observe in our systems and figure out how to actually correlate these different signals that we get from our different systems. And this fragmentation leads to multiple problems. There's complex query languages in each of these different pillars. So you have to, as an end user, you probably need to learn PromQL. You need to learn something for like diving into your logs, and you need to maybe use Jaeger or some vendor-specific language to actually understand what is going on in your systems. And prior to the OpenTelemetry, which we're going to talk about, there was a lot of vendor login because all the different vendors created agents that you needed to install. They had SDKs you needed to use to instrument your applications, which is really, really hard to get out of. So there's a lot of vendor login still. Many of you can probably relate to this. Having these three different signals or pillars also means that it leads to inconsistency between all the metadata. So you're maybe in one system, you are doing uppercase errors or whatever, and in the other, you're doing something else, which makes it really, really hard to actually understand and move between the different systems. And all of this complexity, in some cases, leads to basically no instrumentation, and that, of course, leads to gap in your visibility, and it's going to be hard when things go wrong to actually figure out what is up and what is down and how to resolve that issue. And yeah, you don't get the unified insights because you have these three different pillars that you are looking into. But luckily, there's a shift happening in this space. It's a shift towards correlation. It means that you can now, with OpenTelemetry that I'm going to introduce you to in a second, you can jump between the different signals. It allows you to correlate and find related information across these different pillars. And that makes it easier to reconstruct the chain of events when something goes wrong, because you can jump between the different signals and go from, I think the middle one here shows that a metric is spiking. You can go into the trace, figure out where things are maybe becoming slow, and you can see the logs of that particular time frame, which makes it a lot easier to resolve an issue. And this shift is toward OpenTelemetry as sort of the standard for how we are defining and collecting telemetry across our systems. Just a little bit about OTel. Yeah, OTel for short, that's OpenTelemetry. It's an open source project designed to provide like standardized tools for and APIs for generating, collecting, and exporting telemetry, such as traces, metrics, and logs, but also profiling data soon. This is in alpha, as far as I remember, but also real user monitoring, the browser, the mobile phone. So just imagine having all of that data from the actual front-end client to what is going on in the server and be able to see that as a full trace. That's really, really powerful to have that unified telemetry and correlated across these signals. That is really the goal of this project. It's part of the CNCF. It's still an incubating project. There is, I think the TFC are looking at graduation right now, so it hopefully will graduate in I don't know, before KubeCon, hopefully, we'll see. But yeah, it's really the de facto standard for traces, and then, of course, now also logging and metrics, and soon profiling and real user monitoring. So what it is that it's actually the second largest CNCF project by contributor count. It's also like a data model. There's API specifications. There is implementations of these APIs in SDKs in many different languages. It also has what is called semantic conventions, and I'll come back to that later. It's really just rules for how we are naming things and what units we are using for each of these telemetry. And then it also comes with a collector, which is the agent you will probably install in your cluster. It also has an operator, of course, as every other project has. So it's a lot of different things. I think that the total count of repositories within the OpenTelemetry GitHub organization today is above 80 projects as it is right now. So it's a huge project. But it's not proprietary. It's not an all-in-one observability tool. You will need something else to visualize and analyze and get insights into your data. It's not a data storage. There's no storage at all. It's just about collecting and routing. There's no query language. It's not performance optimized, and it's still not feature complete. So if you are looking for a cool project to work on, go ahead and go in and see what issues are open. I think there's a lot of potential in making this really the standard for how to collect telemetry. Yeah, this is just to showcase that it's way out there with Kubernetes. This was from the report from last year with the CNCF, just showing that it actually surpassed Kubernetes in, I think it's PRs plus issues in total. So it's a really, really, really big project. And there's a lot of momentum behind it. So from 1,000 miles perspective or view, this is how OpenTelemetry sort of looks like and how all the different components are sort of together. Up here, we have like your application instrumentation. You need to instrument your application with, if you're using Java, for example, there's a Java agent that can provide a lot of instrumentation for you. You can also do that yourself. That's really up to you how you want to do that. You probably have a receiver using the OpenTelemetry protocol, OTLP, that sends that to the collector, which is this thing we have in the middle. Then you can do a lot of processing in the middle. You can redact sensitive information. You can do all kinds of things. You can add fields. You can remove fields. That's really up to you. And then you can export and route it to some telemetry backend somewhere. That could be like dedicated things for your databases, for your time series or logs or whatever. It could also be a vendor solution. It could be all kinds of different things. We can also collect things from the infrastructure. For Kubernetes, for example, having the collector running there, the collector can talk to the kubelet, for example, to get Kubernetes information, metrics, all of that. You can get that out of the box from using OpenTelemetry. So that is really what the project is about and how sort of the pipeline looks like if you're using OTel. So Now we have this as like that observability agent you have in your clusters, and then you can route that to wherever you'd like. You can actually send all your data to all of these different vendors or open source projects and figure out what tool makes most sense for my data. It's really, really up to you to use this and figure out what makes sense for you, which is really, really cool. Like, gives you a lot of power as an end user. Yeah, it collects all these signals. I've talked about them. I haven't done a cool graphic for real user monitoring yet. But yeah, this is the signals that are able to be collected. You probably know them already. But telemetry without context is just data. So we need to understand where this telemetry is coming from. Because if we're looking at something like this, any guesses are from the audience what that could be? It's like a graph going up, then it falls down. Yeah, exactly, because without the context, we don't know what this is. So this is actually sort of the number of legs and how cute it is. So you see, without the context, we don't know what this is, what it means, how can we use this for anything useful. And it's the same for your systems, because how are we talking about context for our systems? There's multiple different levels that we can understand a system and where the telemetry is coming from. That could be the infrastructure level, like which data center, cloud region. It could also be the platform itself, like which Kubernetes cluster is this. Then we have the compute. We run this on some nodes, so which container is this coming from, which process. Then we have something on top of that, which is the actual system itself, the service. And then, of course, there's also, in many cases, you probably also want to know who to call when something goes wrong. So you probably also want some organizational tagging or something that this is this team that are responsible for this thing. So there's a lot of different context about a service that you would want to have. So how do OpenTelemetry do this? So this is just an example from the Node.js SDK. There's this concept of resource attributes, which also include resource detectors. In many cases, you would probably get this out of the box because these detectors are part of the SDK. It's already enabled if you use auto-instrumentation. But it's just to know that you can also do this yourself. You can add all kinds of different things to your resources. You can also do that using environment variables. There's this OTel resource attributes. But this is really where you're telling OTel or like the observability pipeline that this is where my data is coming from. This is the context about this telemetry that is being produced. It's also helping to correlate things across the different signals later on in the pipeline, because as a vendor, we for example, use the Kubernetes pod ID to do a lot of correlation between the different signals so that we actually can put things together and make it visible and make it easy for you to jump between the signals. So OpenTelemetry without semantic conventions is just data. That's sort of the next thing. I mentioned semantic conventions. It's this common set of semantic attributes that provide meaning to data when we are collecting and producing and consuming it. It does specifications for all kinds of different things. As you can see up here, events, logs, metrics, resources, and trace. And you can go in and read all these specifications. But looking at the pyramid we saw before, we also have these conventions applied to the different layers that I talked about. So that's general stuff about cloud, like cloud.platform is this thing, it's AWS or GCP or whatever. We also have Kubernetes. There's a ton of different conventions about how to name things in Kubernetes, like KDS pod name or KDS pod CPU usage, and so on and so forth. The compute itself, the process, which telemetry SDK is being used, all this information is defined in the semantic conventions and is sort of the de facto way of naming things in OpenTelemetry. Also, on the architecture level, there's service.name, service.namespace, service.version, all of these things that you can use to tell more about what this thing you have running actually is. Then, as you can see, the organization is not really part of this because this is very specific. There is some projects within the OpenTelemetry space that are working in that area. There's a project called Weaver, where you can define your own semantic conventions. So maybe that's a thing you should look at if you want to put something on top of all of this, because it's really nice to know who is actually responsible for a service. That is sort of the missing piece as it is right now. So why OpenTelemetry? well, you can instrument your applications now only once. You don't have to migrate between different vendors to actually, or SDKs or agents you are running in your cluster to change between vendors. So you can use this standard, and then you can route your data to wherever you want, which is really, really nice. And that's sort of the second point here, is that it separates the telemetry generation from the analysis part. Which is really, really nice, because as mentioned, you can just send your data to whoever, multiple vendors, figure out what makes sense, who provides the most value to you, and choose that particular solution. The other thing is that many SDKs, frameworks you're probably using today in Java, Node.js, Go, whatever, are now observable by default. There's a lot of really, really cool instrumentation in many different projects, which is really, really nice. So you get a lot out of the box, and I'll show you that in a second. And then it also improves how we use telemetry, because, again, we can correlate the different signals. So that's all great, but how do I make it easily accessible for my developers? And before I answer that question, I just want to briefly talk about this dual role you have as a platform engineer in this space. Because on one hand, you are sort of responsible for observing the running infrastructure, right? You're probably most familiar with metrics and logs. That's sort of the signals we use in that space. Whereas the developers are more into probably traces, because they want to understand how my things are propagating, who is my dependencies, all of this. Maybe also profiling, because they need to understand like performance issues. And then, of course, if they do front-end as well, it's more user-related things that are sort of their interest. So that's actually this sort of gap between these two things that is actually quite hard, because who is responsible for actually implementing like a tracing solution? It is of the platform engineers, but they might not see the benefit and the value, because they are only focusing on the infrastructure side. But it is the platform engineer's job in many cases to make sure that developers actually get to a point where they can get out of all of this out of the box. Yeah, so this is just to say that on the different level of the stack, there's different telemetry types that you are probably collecting or needing. I will just jump on that, because I think that my time is running and I need to show the demo as well. So platform engineering for observability, just quickly. You should provide like observability as a product. We talk a lot about platform as a product. Observability should be one of those products within your platform engineering organization. You should provide self-service experience, and you can do that using auto-instrumentation or no-touch instrumentation that we'll talk about. We have the semantic conventions, it's really the explicit APIs. Build it into your golden paths. You can add modularity as well using the collector. It's really flexible. You can do all kinds of cool things in there. Of course, document and support all of this as a product you're building internally. And of course, it's a core requirement that you can now correlate all these things across the different signals. That's all great, but I ask again, how do I make this easily accessible for my developers? And the answer to this question is really auto-instrumentation, which is the Java agent I talked about before, or it could be a Node where you can use a package to do all of this that will instrument your application out of the box. But if you then add the operator on top of this, it sort of becomes no-touch instrumentation. You can add an annotation, and then you will get all of this out of the box, which is really, really nice. And the OpenTelemetry project comes with an operator for that. I'll just focus on this instrumentation part, but it cannot do a lot more, as you can see, because it can add this auto-instrumentation, this Java agent, automatically to your pod. So you, as a developer, don't need to change any code or do anything in order to actually get all of the instrumentation out of the box, which is really nice. So I think these are the 5 languages that are currently supported. There's a small thing about Go, which is currently it uses eBPF to do this, but it is possible, and it comes with, of course, some trade-offs in terms of security, but that's up to you to decide whether you want to do that or not. But observability doesn't stop at instrumentation. We also need to visualize all the data. And for that, we have Perses. It's another CNCF project. It's a sandbox project at the moment. And the goal of this project is really to provide like a specification for your dashboards. So So the goal is hopefully that all vendors at some point start to adopt this. We at Dash Zero are using Perses. I know Chronosphere is using it as well, and a few others. So if all vendors could agree on using an open specification for how you define your dashboard, it will allow you to take your dashboards and move them between vendors, which is really, really nice. That's really the goal of the project. It also comes with an operator, so you can actually do dashboarding as code. That's really sort of where it started. You can also write this in Go. You don't need to use YAML for this. You can do all kinds of cool things. And then to the demo. This is sort of what I will show you. No, it looks a little bit complicated, but I want to show you all the different things I'm talking about. The OpenTelemetry operator, the collector that are collecting the telemetry, send it to different telemetry backends, and show you auto-instrumentation. So let me just do that. So let me just clear this. Hopefully this is big enough. Yeah, it looks big. So this is just a simple kind cluster that I have running on my machine. It has a few things. We have an operator. This is the OpenTelemetry operator that I was talking about. We have a few collectors, one on each node as like a daemon set deployment. It's used for collecting kubelet stats, all the node-specific things. This one also picks up logs, etc. And then I have a central one for more cluster-wide telemetry, like how many replicas of a deployment do I have running, stuff like that. Then we have the Perses operator, which is managing a Perses instance at the moment. I'll show you that in a second. And then I have my two applications. Backend, it's a to-do application. I have a backend written in Java and one written in Go, just to show you sort of the differences. Have a front end, have some databases I use underneath, and then I'm using Jaeger for tracing, Prometheus for the metrics, and then OpenSearch for logs. So let me just quickly show you the So this is the Java application. As you can see, this is just sort of the Spring. Let me just find the controller instead, because that's more interesting. The thing you should note about this particular piece of code is that there's no instrumentation. There's nothing like I'm counting up a metric or I'm doing something. There's nothing in here. It's just a regular Spring Boot application that is an API. It's very simple. And I want to instrument this now. If I can exit. There we go. Wow. Clear. And the way we do that is by using this thing called instrumentation. The instrumentation resource I talked about before looks like this. It's a kind instrumentation. It has a name. It's being deployed in a namespace. And then you define where your exporter is running. So in this case, I'm sending this to the collector I have running in my cluster. I can add some things about sampling if I want to do this. So for the demo here, I want everything to be there, so always on. You could also do sampling if you do like many requests and you want to filter something out. I add KDS UID attributes because it's really good and easier for the backends to understand where this is coming from if you add the UIDs of the actual instances. And then I add a specific image for Go because there's some interesting stuff in that ecosystem. So let me just quickly apply this. Instrumentation YAML, yes. And as you can see, nothing really happened to my applications. My two applications down here didn't do anything. That is because you need to opt in. So let's just do that. So if I edit, let's take this one. No, what did I do? Okay. Anyone spotting my mistake? Ah, yeah, that's the pod name. Ah, wow. There we go. Thank you. So, in the pod spec, we have down here, we add an annotation. We put in, not this one. Let me go out again because now my clip holder is not using the right one. Sorry about this. I have a README where we have the annotation. I can copy. There it is. Oh, live demos are always fun, right? Labels, annotations. spelling it correctly, inserting. So there we have it. So what we are telling now, or telling this to the operator, is that we want to inject a Java agent into this application, and it should get the information from this OpenTelemetry instrumentation resource I showed you before. Let's save that. And we can do the same for Go, just real quickly. There we go. And instead of Java, we want Go instrumented. So let me just clear so you can see it better. Let's see if the Wi-Fi is working. Let me just put this on. There we go. So as you can see, it restarted the pods. And now I can copy this, because let me just show you what it did. I can describe this pod. And you can see the operator now injected a lot of different things. It injected a lot of the OTel environment variables, like this is a container name to do, it's running, this is the deployment. All of this is following the semantic conventions I talked about. Then it also comes with this Java tool options that instructs the Java or the JVM to actually run this Java agent along with the application, that is coming from an init container that is managed by the operator itself. So that is how it sort of injects the Java agent into the Java application, and then you get instrumentation out of the box. You can, by the way, try this out yourself. I have a QR code at the end, so if you want to try this, you can do it yourself. But let us try and send some requests. Hello, ContainerDays. Wow, Daisy. Let's just do the Java one. And go, copy. Hello, ContainerDays. There we go. So this is just a simple front end that sends requests to the different backends, and then hopefully we'll see some, it's right here. So as you can see now, this is Jaeger. This is where we can visualize all our traces. We can go in and see all the Go traces. You can see there's stuff here, but the Java one is more interesting. Java is a little bit more mature on this, so it's a little bit more interesting to see the different spans. So we have this post request. So what you can see is you get like the client span on the actual insert into the database. You can see, okay, insert this. All of this comes out of the box. I didn't touch anything in the code. You get all of this out of the box. You get like durations, all of this on the post. You can do all kinds of interesting information, or you have a lot of information about your system by just adding this Java agent, which is awesome. Last thing I want to show you is Perses as well. I have this bad Perses. Perses has this CRD called the Perses data source, where you define where my metrics are. In this case, I'm using Prometheus, so I can define a Prometheus data source, and then I just point to my Prometheus server that I have running in this cluster. Let me just apply that real quick. Perses, Prometheus, there we go. And then we have Perses dashboard as well. So this is a Perses dashboard, as you can see. So you define like different panels. We could also, so once you've laid out all of these panels, let's just go down. Then you, there's a grid view, and then you can place all the different panels as you like. So you can define all of that either in YAML, in Go, in Q, I think as well. So there's all kinds of options for how you're defining these dashboards. And let me just quickly show you sort of the result. Perses JVM, there we go. Go back to my browser. So this is Perses. And once I refresh, I get a default project because I didn't specify a project. And then I have a dashboard here, which is the JVM dashboard that I just created. And you can see metrics are now starting to come in. So this is basically how you can do dashboards as code using Perses. And again, if all vendors can at some point adopt this, you can take this dashboard and you can put it into all the different vendors you want to test out, for example. Use OTel to send your data to that particular vendor and copy your data dashboards over. That will be a very powerful future if that is possible. So hopefully push your vendors to adopt Perses. That would be awesome. Okay, so that was the demo. Yeah, so what you just saw was that we didn't touch any code at all. We used the OpenTelemetry operator and this instrumentation resource to specify how instrumentation should happen for a Java application and a Go application. I don't know if you noticed, but the Go one had like 2 out of 2, which was the eBPF sidecar container. I didn't really mention that, but it runs a sidecar, as you can also see up here, it's visualized. And you need to specify the binary that's running in the application container to get this to work. It's simple, but it can be done. Then we used the collector to collect all the telemetry, and we forwarded that to Jaeger in this case and Prometheus for the dashboard you just saw. And that's basically how easy it can be for you to provide all of this to your developers. Of course, like as things grow and you get more mature, and you probably need to add some additional things within your systems to get more visibility into certain areas or whatever. But you can always use auto-instrumentation to sort of get started, and then you can add additional. You just need to like import the SDK, and then you can start adding additional spans to the trace, which is quite nice and very easy to do. So observability is evolving fast at the moment. There's a lot of things happening, and OpenTelemetry is really standardizing how to collect telemetry across all of these different systems. Hopefully, Perses will be standardizing dashboarding. I need your help for that one. I'm trying to push this as hard as possible because I really think it's powerful to come up with an open standard for how we're defining our dashboards and can be able to use that across different vendors. And if you apply like these platform engineering principles, you can really transform observability from this afterthought that it is in many cases into a simpler, seamless, scalable, and developer-friendly experience. Just imagine you're having your developers basically just deploying their application, and they get out all of this out of the box without having to touch anything or do anything. That's really powerful. And you can easily do that as a platform engineering team. And again, observability is not a systems problem. It's not a tracing, or it is a systems problem. It's not a tracing, logging, or metrics problem. So treat it like that, because when we connect these signals together, we really empower developers to solve problems faster. And last but not least, building on these open standards really allow you as an end user, as a customer of many of these vendors, to move freely between these different solutions and really like test them all out and figure out what makes sense for your data. So it sort of pushes us to always stay on the toast and really provide you the best possible experience. Yeah, shameless plug. If you are in the hotel space and you're struggling with your OpenTelemetry collectors, we at Dasero created this thing called OTelBin. It's an open source tool out there. It's really nice to visualize your collector configuration and validate it against different versions or different, so I'm not sure if you're familiar, but there's different distributions of the OpenTelemetry collector. Up here, you can see this is a collector contrib, so you can actually test if the things you're trying to use is part of that like distribution. It's quite nice, and it also visualizes the entire pipeline for you. So I think with that I am almost at time. If you want to try the demo yourself, you can scan this QR code or find the demo on GitHub. It should be fairly easy to get up and running. Otherwise, just ping me. Thank you.
You can ask questions using the ContainerDays app or just scan the QR code now. Then we will see your questions on the stage.
I can try and answer that one. I hope so. Because right now Grafana is really like a proprietary kind of solution. I really hope we can define and use like an open standards to define how a dashboard looks like. If it's realistic, I guess time will tell. I think that I see more and more different vendors now trying to look at this space, but of course this is a sandbox project. It's really early, but I think it's really powerful to have like a specification and an open standard for this. I'm all into open standards, so I hope that's where we'll land, but we'll see.
This yellow means that I marked this as done. Okay.
Oh.
Okay, there's another question. Do you know? Okay. Oh, wow.
I know. Thank you. Wow, stuff is happening. Do we have time?
We have still a few minutes.
Okay.
I will.
How's the development flow with Perses? It's really up to you. I saw Siam, I think his name is called. He just did a really cool video, I think last week on Perses. You can probably find it on YouTube. Otherwise, come talk to me and I'll show you. But he showcased the Go setup, so you can define a Go file where you lay out your dashboard and just use the Perk CLI, which is the Perses CLI, to actually generate a YAML file if you like that. You can do YAML as well. It's probably not what you want, but you can do that. You can, of course, also go into run the server locally, as I'm doing here, and define and set up and lay out all the grid, all the different panels, and just export it and put it in your GitHub repository. I don't think we have the golden solution for like clicking and putting it into a Git repository, automatically syncing and all that. Oh.
How about alerting? Maybe
How about
that's
alerting?
the last question, and then after that you can reach out.
I can take the alerting one. So for alerting, I think that's the Prometheus operator is really nice. We use the Prometheus operator at -0 as a standard, so the Prometheus rule. I think if you're using that ecosystem, use the Prometheus rule to get alerting as code. Or if you want to try -0, you can use the Prometheus rule as well there. So it's really an easy way. So I think Prometheus rule is really sort of the default in that space right now. Whether that will be like a standard in the future, I don't know. We just chose it because it's what probably the most prevalent standard out there as it is right now. So use Prometheus rule for your alerting as code.
Thank you.
Thank you.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.